IGCSE Chemistry Lesson 6. We are going to cover pages between 162 to 163. The topic of today is the mole and chemical equation. Previous session we studied about the relationship between mole and chemical formulate, but today we are going to understanding the relationship between the mole and chemical equations. First of all, we need to learn about the law of conservation of mass. Uh, it states that no atoms are loose or made during a chemical reaction. Instead, atoms joins together and they make different figures. And so, since atoms are not lost or made during the chemical reaction, total mass of products, reactants is equal with the products. Okay. Here there is one example of reaction between copper and oxygen. Uh, After the reaction, we will have the same number of atom as reactants. Okay, like two copper in as a reactants and two copper in which is involved in products, and two oxygen and two oxygen. So during the reaction, the number of atoms or type of atom are not lost, are not lost, are made. They are remain stable. Also, same uh, the total mass of uh, products and reactants are same. Okay, since we don't have uh, lost or made atoms, of course the mass uh, has been stable, has been constant. Then another example, like the reaction between iron and sulfur, and 1 mole of the iron and 1 mole of the sulfur would be same 1 mole of this compound. I the yeah the Here we can see the mass of iron, which is 56 gram, and for sulfur is 32 gram per mole, and the total mass of product is same with the total mass of reactants. Okay. Next slide shows that this law can help to manufacturers in industrial uh, environment. The people can estimate how much reactants they need and how much product they can take from a reaction. This type of reaction can be used in industrial or commercial uh, manufacture. Like this is the uh, when calcium carbonate break down to calcium oxide and carbon dioxide. Okay, so 1 mole can be broken down to 1 mole calcium oxide and carbon dioxide, 1 mole carbon dioxide, and the total mass of uh, reactants can be equal with the total mass of uh, reactants products. So in this case we can estimate, we can extend the amount to the tons just using the same ratio. 100 gram can be used as a 100 tons, and 56 gram can be estimated for 56 tons, and 44 gram can be estimated can be expected for 44 tons. That means each 100 tons can produce uh, 60, 50, 56 tons and 44 tons carbon dioxide. So in this, by the law of conservation of the mass, we can predict to larger scale. Okay, and um, another point is, for example, uh, if you, for example, if we don't know how much carbon dioxide will be produced, uh, based on this law, which says the amount of mass in products, the total mass of the product is equal with the total mass of the reactants. So we can estimate, uh, we can expect that how much we can take from the carbon dioxide. If we uh, 56, if we just calculate a minus 100 minus 65, the rest will be 44. This is a very simple relationship. For next slide, we can predict by calculating reactants amount, a chemical footprint. This is a strategy to find how much gram we can expect for production, uh, or in or maybe how much we can product, and how much we can expect for reactants. I'm following your book, which gives a one question, that is, what mass of aluminum oxide is produced. Okay, this is the question, and that means we are looking for the amount of mass for aluminum oxide which will be produced when 9.2 gram of aluminum metal. Okay, only aluminum metal. Okay, it's not compound, it's just uh, is elements. Okay, if we have 9.2 gram aluminum react with oxygen gas, O2. So the only value which the question give us is 9.2 for aluminum metal. And for the answer, first we need to write a equation to find the equation with correct balanced mole. Aluminium plus O2, and the product is aluminum oxide, Al2O3. Then we need to uh, balance the moles 432, and this flow chart is very helpful to find your answer. 9.2 gram is the value of the mass of the reactants, that means aluminum. Okay, this aluminum is 9.2 gram, is a mass value which question give us, and we are looking for the same unit, gram, for the mass of product. This is our target. Okay, what we need to do first, we have 9.2 gram to as a mass of the reactants. We need to convert these to the number of the mole of the reactants. from the mass of reactants to the mole of the reactants. The number of mole, as we learned before, is amount of the mass we have, and the number of the mass value which can be obtained from the periodic table. The mass of the aluminum is 27 gram per mole. So the answer, the value for the number of moles is 0.34 moles. Okay, for each aluminum. So the number of the reactants is 0.34. Now we want to reach to how many moles for products. Take a note that for this equation we are not concerning for oxygen. Oxygen is not involved in this question. We are just focusing on aluminum, which can produce aluminum oxide, and we are looking for the amount of the mass of aluminum oxide if we have 9.2 gram aluminum. We are not focusing on oxygen, it doesn't matter. So now we need to jump from the mole of reactants to mole of the products. How many moles we have from this? Okay, you need to use the ratio from the equation. Check the ratio from the equation. Each for aluminum, okay, from each for aluminum we got 2 mole aluminum oxide. That means a half products from our reactants. Reactants is aluminum. Each for aluminums we can take 2 aluminum oxide. Okay, this is a very simple relationship. From each four we get 2. From 34 here, from 0.34, how much? This is x. Okay, it's not we are looking for this value. So here a simple equation, 0.34 can be multiplied to 2 and divide to 4. Okay, this is a times multiplication. Okay, the x equal with 0.34, 2 times to 2 divide to 4. The answer is 0.17 mole, a half of 34. Actually, this is a very simple. This relationship can be used for more complicated number, but here the values are very simple. You can say that, okay, from 4 we can get 2. That means half. So half of the 0.34 is 17. This is simple, but I wrote this equation that you can use it for another type of question which is complicated, which has complicated values. So we reach to 0.17 mole for the number of moles of product. That means this. Here we can say if we have 4 aluminum, we can get 2 mole aluminum oxide. If we have 0.34 number of aluminum, we can get 0.17 mole aluminum oxide. This is a very parallel relationship between these two. Now we are going to reach the mass of products from the number of products to the mass of products. Here, from the previous calculation, 0.17, again we use the same relationship, same formula. which is the number of mole, is equal with the amount of the mass to the mass value from the periodic table. This is available um, at the first session of this chapter. If I'm not mistaken, we learn how to calculate a mass of a compound. We have 2 aluminum, we have 3 oxygen. The total is 102 gram per mole, which you can take from the periodic table. The number of mole is here, so these two can be multiplied 0.17 mole times to 102 gram, and the amount of mass is 17.3 gram, the amount of mass of products. So this is the answer, and you need to memorize and practice how to find a relationship between mass to number of mole, and from the number of the mole of the reactants use the same ratio, use the ratio of the equation. From the mole of the reactants to mole of the products, again from the mole of products, how to convert to the amount of mass of products. This is a relationship between the number of mass to moles, and moles to mass, and also use the ratio through equation, chemical equation. That's all for today. Hope you are studying well and progressing well. Please leave a comment down as your attendance. Thank you so much. Take care.